will formulate the table the way I have told you. The same manner you can formulate the table and proceed. Okay, so using the steps here in the revised simplex method, actually we are using some inverse, some specific inverse, that is the product form of inverse to compute the inverse of a basis matrix. Generally, the basis matrix what you are considering, there is a square matrix. So we are searching solution for the non-singular matrix, not for the singular matrix. Okay. So why it is not singular? So it is obvious because you know the key elements we are not considering 0. So always positive, and specific rule we are also applying. So assume that this matrix is non-singular. And how we are using the product form of inverse. So I have already told. Anybody has missed my yesterday class? I want to repeat it. Anybody has missed? Anybody has missed the last minute class what I have taken yesterday, the 2-hour class? Anybody has missed? Yes or no? Are you able to hear?
Sir, could you briefly once explain one example of revised simplex method again?
See, in last class I have given this slide also, but we are discussing about the product form of inverse. Okay, so I will request everybody. So when I'm computing a problem, you also parallelly proceed. I'm not going to cover very quickly. Slowly we'll cover. Okay, so this main purpose is we are using the product form of inverse to compute the linear programming problem, to find the optimal solution. As you know, a linear programming problem, so may be infeasible, may be feasible. If it is infeasible, so certainly there is no solution. If it is feasible, it has either a unique solution or infinitely many solutions. So if somebody programming problem, it is possible, but for the linear programming problem, these are continuous type of variables. This x1, x2, x3 in this problem, they are continuous variables. It may happen. The problem has, in the last class, we are discussing a problem. This problem has infinite number of solutions. We have got 2 solutions. Using 2, we can generate infinitely many solutions. If you find, say, 2 solutions, then suddenly, so you can generate infinitely many. Okay. So this is a problem. So we like to solve it using the revised simplex method. See, there are 3 inequations. This first inequation, x1 plus 2x2 plus x3 less than or equal to 16. x1 plus x2 plus 2x3 less than or equal to 14. 4x1 plus x2 plus x3 less than or equal to 12. There are 3 inequations. If somebody forcibly think maybe there are 3 equations. So 3 equations, you can solve it 3 unknowns. How do solve? Using the matrix inversion method. Okay. So see, there may be a chance that there are 3 equations. Okay, there are 3 equations. So this, you know, the inequations are bigger set. Okay, the equation is, you know, once it is equation, so it has, we assume that maybe one solution or infinitely many solutions, depends on the problem. But see here, it is given in equation. So once it is given in equation, we will not make forcible equation. See, it may happen. So you will find solution if you are solving 3 equations. First equation, x1 plus 2x2 plus x3 equal to 16. Second equation, x1 plus 2x2, x1 plus x2 plus 2x3 equal to 14, and last one is 4x1 plus x2 plus x3 equal to 12. So somebody is taking 3 equations and solving, and he is finding a point. That is the maximum. And you say that yes, that is also my minimum. If it is instead of maximum, it is minimum also, you say that is minimum. So it may happen, but we will not proceed in that manner. We have to proceed using the simplex procedure, simplex method procedure. Okay. What exactly you are going to do? There are 3 inequations. Right hand side, this B value, B1, B2, B3, presently here 16, 14, 12, they are non-negative. If they are non-negative, generally we use here slack variables. We introduce three slack variables. The slack variable for first inequation, S1, for the second inequation, S2, for third inequation, S3. S1, S2, S3, three slack variables. If somebody say that instead of X2, X3, X5, X6, no problem. But you have to mention this X4, X5, X6, they are slack variables. Presently, I am saying S1, S2, S3 are the slack variables. Please note down this problem because I will not come back to this present slide. So please note down this problem because you have to solve it and you have to help me say whatever the way you are computing the steps, whatever I have discussed, the same step or not. Okay, please note down this problem. This is the problem. If you say yes, then I will go to the next slide. I hope you have paper and pen, please, because you cannot remember so many steps. Very simple problem I have taken. So 3 inequations and 3 variables. Okay. So my purpose is we are going to consider the basis. Example, we have taken basis matrix of size 2 by 2. Okay. So at 2 by 2, they are simpler. So 3 by 3 may be little. So lengthier, you have to compute that. Okay. So this is the problem. Once you are introducing slack variables, so this problem, once you are introducing 3 slack variable S1, S2, S3, the problem can be written in this manner. This is all right? The second slide, second page. So what you have done, we have introduced 3 slack variables, namely S1, S2, S3. Okay, slack variables. The slack variables are generally basic variable. And sometimes if there is some artificial variables, they are also basic variable. But the surplus variables are not basic variables. I am repeating several times. Slack variables are basic variable. Artificial variables are basic variable. But presently in this problem, we have 3 slack variables. Okay. In this problem, altogether there are 6 variables. X1, X2, X3. These are the original variable. We say the control variables X1, X2, X3. There are unknown variables. Know the value of X1, X2, X3. And we have introduced 3 slack variables. S1, S2, S3. What is the purpose? Because anyhow, we are going to solve the system of linear equation. There is no other option. But we are solving the system in a different manner. So we are looking for basic feasible solution. Why basic feasible solution? This X1, X2, X3, these 3 variables are non-negative. S1, S2, S3, these 3 variables are also non-negative. So there are altogether 3 plus 3. 3 plus 3. There are 6 variables. So if you want to find the basic feasible solution without using the revised simplex method, 3 plus 3, there are 6 variables. And there are 3 equations. Okay. Let me say the rank of this matrix rank equal to, let us say 3. Rank equal to 3. Okay. So if they are linearly dependent, may not be rank equal to 3, but here in this example, rank equal to 3. If rank equal to 3, so we have to select 3 variables, 3 one category, 3 other category, 3 basic variables, 3 non-basic variables. Out of 6 variables, we'll make 3 basic variables and 3 non-basic variables. How many way you can select? That is 6C3. 6C3 means how many? Tell me how much it is. 663. 6 into 5 into 4 divided by 6. So 5 into 4. How many ways?
20.
20 ways. So you will find 20 basic feasible solution. Okay. So after finding 20 basic feasible solution, if you are not using any simplex method, you can conclude what is my optimal solution. That is maximum number of basic feasible solution. We have maximum number, that is 20. This is upper bound. Cannot be more than 20. Okay, 20. So we are not going for that. See, initially, if I am considering, you see here, x1, x2, x3. These are the actual variables. Slack variable s1, s2, s3. Three slack variables. If I am setting x1, x2, x3 all are 0. x1 0, x2 0, x3 0. We have three basic variables. Their value s1 equal to 16, s2 equal to 14, s3 equal to 12. Now at this point, since the value of the variable, actual variable x1 0, x2 0, x3 0, it will not give maximum solution. It will give us minimum solution, not maximum. If it is instead of maximum, if it is minimum, then 0, 0, 0 is the optimal solution. Instead of maximum, if it is minimum. But this problem is given maximum. Okay. So S1 equal to 16, S2 equal to 14, S3 equal to 12 is not a optimal solution. It is a basic feasible solution. Is it clear? Okay. Now, so considering this system, we are formulating a simplex table. This is my simplex table. And I have told for the revised simplex method, you need extended simplex table. Extended table. In the extended table, all 6 variables for them, we have 6 different columns. You can see here. So this problem, whatever I have presented, this problem. So I am presenting the tabular manner. So there are 6 variables. So we will rename in this manner. There are 6 variables. In short, I am writing here B. Variables are x1, x2, x3, s1, s2, s3. These are 6 variables. And out of 6, presently s1, s2, s3 variable, 6 columns there for 6 variables, and 3 rows are there, s1, s2, s3. These 3 rows for 3 basic variables, s1, s2, s3. These 3 rows are 3 basic variables. Now you can see here. So above x1 there is 1, above x2 there is 4, above x3 there is another 4, s1 above s1 there is 0, s2 0, s3 0. So this say that the coefficient of the variables for the objective function 1, 4, 4, 0, 0, 0. So all variables are there. Their coefficients 1, 4, 4, 0, 0, 0. All are fixed here. Okay. Now these basic variables S1, S2, S3, CB. CB stands for coefficient of the basic variable for the objective function. Okay. PV stands for the basic variables S1, S2, S3. CB coefficient of the basic variable 0, 0, 0. Okay. Now in the right hand side, I have told already. So if you are setting x1 0, x2 0, x3 0, s1 value is 14, 16, s2 value is 14, s3 value is 12. Okay. Now the last row, the indicator row element -1, -4, all 3 0. Then the objective function value 0. This I have to, using the revised simplex rule, we will establish. Okay. How it has been established, I will tell you. -1, -4, minus 4. Okay, this table, at least this table you please note down. Is it possible? This table? Otherwise there will be problem. Say, another thing I want to say, with respect to first column, that is variable x1, this column we name P1. This has 3 elements, 1, 1, 4. Then with respect to variable x2, there is a column having 3 elements. The elements are 2, 1, 1. 2, 1, 1. With respect to variable 3, there is a column. Okay, so there are 3 elements. The elements are 1, 2, 1. So we are naming for the first column P1, second column P2, third column P3. And there are 3 different columns for the basic variable. So that is P4, P5, P6. You can see here S1, S2, S3. These 3 columns, S1, S2, S3, these 3 columns formulating a identity matrix. Can you see here? S1, S2, S3, they are forming a identity matrix of size 3 by 3. 3 by 3. There are 3 basic variables. So identity matrix of size 3 by 3. And this is, so the identity matrix has same inverse. Initially, the basis matrix is our identity matrix. B is having elements 1, 0, 0, 0, 1, 0, 0, 0, 1. 3 rows. You can say 3 column also. Okay. So this is the basis matrix. Now, initially, this is our basis matrix and inverse is also same. And right hand side value 16, 14, 12. This much information I am storing here. Only one table, no other table is required. No other table. Whatever will compute from this table only. Okay. Even the last row, whatever I have written, -1, -4, etc. In the last row, that and even the coefficient, 0, 0, 0. This is actually in the initial simplex table. This coefficient CB and the indicator row elements are different. So in the new table, I am not drawing any other table. So other information remains same. Other information remains same. The columns I am not changing. Okay. The value of XB I am not changing. The B column. The elements are 16, 14, 12. I am not changing. Everything is fixed. Okay. Now I will go to the next slide. This you have noted down?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Okay. Now I have told you something. This basis matrix is our B. I am naming the basis matrix is B. And its inverse is B inverse. Initially, this is given. And P1, P2, P3. P1, P2, P3. 3 column vectors. P1, P2, P3. These are 3 column vectors with respect to if S1, S2, S3 are the basic variable, then what are the non-basic variable? What are the non-basic variable? The complement. Out of 6, 3 are the basic variables. Rest 3 are the non-basic variable. X1, X2, X3. Okay. So other I am not writing. So it is obvious. If you consider P4, the elements will be 1, 0, 0, P5, 0, 1, 0, P6, 0, 0, 1. It is obvious. The identity matrix 3 different column. Now, basic variables S1, S2, S3. These are the basic variables we have named. So I am following the step of the simplex method. It has 3 different steps. So we like to discuss step 1. Step 1, we want to know what is our basis matrix. Initially, the identity matrix is the basis matrix. Okay. So why? Because if you say x1, x2, x3, 0, then there will be 3 equations and 3 unknown. S1 equal to 16, S2 equal to 14, S3 equal to 12. So this is actually giving 3 equations, 3 unknown. it is square system, and you know the coefficient matrix is an identity matrix. So that is the reason we are writing. So the basis matrix is this. Okay, because once you are setting, actually this is actually Ax equal to B. Once you set the non-basic variable 0, this A is becoming capital B. B into XB equal to B. B into XB equal to B. So XB equal to B inverse into small b. Okay, that I have already told. So no question of repeating here. So this is now CB. What is CB here? CB is the coefficient of the basic variable for the objective function. Presently, how much it is? See here, 0, 0, 0, 0, 0, 0. Actually, it is a column vector. 0, 0, 0, the coefficients. Say x is a column vector. X1, you know, when I'm saying this x is a column vector, so C is a column vector. So the coefficients of the basic variable, it is a column vector also. There are 3 0. Okay. So actually I'm writing here. So CB transpose. Coefficient of the basic variable transpose, because I meant to make it row. Okay. Row. So the elements are 0, 0, 0. Now from the steps of the simplex method, so y equal to, y is a row vector, y equal to CB transpose into B inverse. Y equal to CB transpose into B inverse. With this B inverse, multiply CB transpose. 0, 0, 0, multiply the identity matrix. This will be 0, 0, 0. Is all right? Can you verify?
Yes, sir.
Okay. So CB transpose, initially it is becoming 0, 0, 0. Okay. So y equal to CB transpose into B inverse, it is also 0, 0, 0. Okay. Now, next step, basic variables are S1, S2, S3. Non-basic variables are X1, X2, X3. With respect to the non-basic variable, for all the non-basic variable, calculate the indicator row elements. What is that? Indicator row element will be Zj minus Cj. This actually, this is nothing but y into Pj minus Cj. Y into Pj minus Cj. This y equal to 0, 0, 0. And what is P1? 1, 1, 4. Pj, j equal to 1. For j equal to 1, we will have Z1 minus C1. So y into Pj, 0, 0, 0. If you multiply it with 1, 1, 4, how much it will be? How much it will be?
0, sir.
0, 0 minus Cj. Cj
Minus
equal
Cj.
to j equal to 1. See, that is, this 1 is C1, this 4 equal to C2, this 4 equal to C3, and these are nothing but, you can say, this is actually our C4, C5, C6. If you name in this manner, S1 equal to next variable X4, S2 equal to X5, then S3 equal to X6. These 3 0, these are nothing but C4, C5, C6. Okay, that is already there. You can see 0, 0, 0. So that is y into Pj, that is a 0 vector, multiply. So this is coming 0, 0 minus 1. 0 minus 1. How much it is? Minus 1. Okay. Z1 minus 1 equal to minus 1. Then similarly, Z2 will be y into P2 minus C2. So Z2 minus C2 will be y into P2 minus C2. So P2 2, 1, 1. P2 is 2, 1, 1. Now multiply. If you multiply, how much it come? In first table it is 0. Minus
0,
4.
sir.
That is minus 4. Similarly, Z3 minus C3. So y into Pj, y into P3 minus C3. That is also minus 4. So what I have written here, minus 1, minus 4, minus 4. And similarly, other elements, this will be, you can see, verify, they are also becoming 0, 0, 0. Okay. And if you multiply 0, 0, 0 with 16, 14, 12, that is also 0. This -1, -4, -4, these are the indicator row element for the non-basic variable, non-basic variables. We choose the most negative element. What is the most negative element? -4. There are two -4. Since there are two -4, you can select one of them, either the second column or third column, whatever. Because if there is a tie, you can break the tie. Arbitrarily, there is no harm. Okay. So generally, the biggest one we are considering. So biggest is -4 in terms of the negative coefficient, -4. So what is the conclusion? The conclusion is like this. So with respect to this minus, so -4, -4, I am selecting x2. So x2 is the entering variable. x2 is the entering variable. With respect to x2, we have an entering vector. What is the entering vector here? P1, P2, P3. Which one will be the entering vector?
P2,
Yes.
sir. P2.
Either P2 or P3. Okay. If you are considering x2, then it is P2. If you are considering x3, that is P3. Okay. So x2, with respect to x2, there is an entering vector. P1, P2, P3. So P2 is the entering vector. Please remember. Okay. So now we have the entering variable. What is the meaning of x2? x2 say that this x2 was a non-basic variable. Okay. So now it will become the basic variable. There are three non-basic variable, three basic variable, S1, S2, S3. Since x2 is becoming a basic variable, so we have to give some house. So where it will be, you can place in the position of S1 or S2 or S3. So out of these three, we have to see where you can place in this S1 position or S2 position or S3 position. Why? The reason is like this. This S1 is representing the fourth column. S2 representing fifth column. S3 representing sixth column. Okay. So where you can replace, whether in the fourth column or fifth column or sixth column. Okay. So you have to see where you can replace, how will replace. Okay. See here. Now the step 1 is complete. Now I am coming to the step 2. Okay. See, in this problem, we are computing the inverse in a particular manner. Inverse of a matrix in a particular manner. That inverse we are using always. Okay. First step, then again we are changing some column, then we are computing the inverse, then we are using the same inverse, basis inverse. Now see here, xb equal to B inverse into B. Okay. B inverse is the identity matrix. The B elements, the B vector elements are 16, 14, 12. 16, 14, 12. Okay, this. So xb into B inverse into B. How much it will be? xb? B inverse into B. Tell me. B inverse. See, already I have told B inverse is identity matrix initially. We have not changed. That remain. So in the step 2, what is our xb? Will it be 16, 14, 12? Please check.
Yes, sir.
Now, I have told you, so since x2 is the entering variable, p2 is the entering vector. Okay, with respect to p2, we will compute alpha 2. What is p2? So p2 is representing the column for x2 in our table. Okay, p2. So B inverse into P2, that is alpha 2. You can see here, B inverse into P2, that is alpha 2. This alpha 2 is same as P2 because presently the matrix is identity matrix. There is no change. So elements of P2 is same as alpha 2. Okay, the elements are 2, 1, 1. Is it all right? Now what we are going to do? We'll find the minimum ratio in this manner. 16 by 2, that is 8. 14 by 1, that is 14, 12 by 1, that is 12. So you can see here, we are finding the minimum ratio, minimum positive ratio, 16 by 2, 8, then 14, then 12. What is minimum here? Minimum is 8. That minimum is coming with respect to the first element, these two. Okay, in the simplex table, these two is our key elements. But here we are not talking about the key elements. Okay, we are talking about the pivoting elements. We like to find the inverse of the matrix using the product form of inverse. Now, so the minimum ratio, say, with respect to row number 1, there are 3 elements. This 2 is with respect to first row, 1 is with respect to second row, this one is with respect to third row. So with respect to first row elements, so we have minimum ratio. So it says that there are 3 basic variables, S1, S2, S3. S1 with respect to first row, S2 with respect to second row, S3 with respect to third row. So since it is representing first row, S1 is the departing variable. S1 is the departing variable. S1 is the departing variable. And which one is the entering variable? P2 is the entering variable. X2 is the entering variable. P2 is the entering vector. Okay. Now, see S1, see here. This is our P1, 1, 1.
Sir,
P2,
S1 is the departing
P2 is
variable.
2, 1, 1. And S1 is 1, 0, 0. Okay. So this 2, 1, 1 and 1, 0, 0, what will do? So in the basis matrix, first column will replace by the P2 here. So S1 is selected as the departing variable. Hence, the first column is with respect to basic variable S1 of the basis matrix. B is replaced by P2. Once we are calculating in this manner, our nest basis, B nest. Earlier it was B, now it is B nest. So first column we are replacing with 2, 1, 1. So 2, 1, 1, next column 0, 1, 0, next column 0, 0, 1. This is the basis matrix. So once you have this is the basis matrix, can you find the inverse using the product form of inverse? Very simple.
Yes, sir.
Can you find the inverse?
Yes, sir.
This is the B nest. Once you got the B nest, so we can, the basis matrix, we can find its what? Its inverse. Its inverse can be computed in this manner. See, in the first column, with respect to 1, 1, we are finding a eta. So that eta we are replacing in this identity matrix in the first column itself. This 2 is becoming the reciprocal half. Then these 2 we are dividing by other elements. So minus 1 by 2, minus 1 by 2. So our B nest inverse, the elements are half, 0, 0, minus half, 1, 0, minus half, 0, 1. This is same as our E1. Because with respect to 3 by 3 matrix, we'll have E1, E2, E3. Presently, so we have, what we have done? We have replaced in the first. So in the first column we are replacing because S1 is the basic variable. So in place of X1, so we are placing X2. So this 2, 1, 1, once you replace, that is your B nest inverse. Is it all right? Please check. Is it all right? If you say right, then I'll move to next step.
Yes, sir.
It is very simple. No need of, when you compute inverse, so we do so many things. Here, we are not doing many things. Simply we are using some multiplication, matrix multiplication. Okay, this B nest inverse. This is nothing but we can name as E1. Presently it is E1. Okay. So now once this new inverse is obtained, new basis matrix and new inverse is obtained, what we'll do? So we will set this. We have old inverse, the new inverse. Okay. So this basis matrix is our new basis matrix, and this inverse is our new. So we'll write in this manner. So set B inverse equal to B next inverse and go to step 1. What you have done? So we have, using the identity matrix, that is basis matrix is the identity matrix, we have got entering variable, entering vector, departing variable, departing vector. Then we have got our B next, a basis matrix, a new basis matrix. So this new basis matrix, from the new basis matrix, we are finding the new basis matrix inverse. That's all. So these 3 steps will follow always. Okay. Now I'm going to next step. Step 1. Okay. Step 1. What is that? See, next step means 3. After completing the 3 steps, it is already given. Go to step 1. Okay. See, when you can stop, if you see that the present solution is optimal, there itself we stop and find the optimal solution. So we have not reached the optimal solution because there was a negative elements, and there are 3 negative elements. So we'll see whether that negative elements are there or not. Okay. Presently this is your B and B inverse. These are known. Okay. So every step. So after completing the first 3 steps, step 1, step 2, step 3, I like to remind you from the table here. So this, what is happening? S1 is becoming non-basic variable. Then which one is becoming basic variable? Which one is becoming basic variable?
X2.
X2.
So presently the basic variables are X2, S2, S3. Presently the non-basic variables are X1, then
S1.
S1, then X3.
X3.
So this you have to write down. I'm writing here. Basic variables are X2, S2, S3. Okay. There is no option to write there. So non-basic variables are X1, X3, S1. Okay. Earlier, blindly we are writing S1, S2, S3 are the basic variable, X1, X2, X3 are the non-basic variables. So this X2 is becoming the basic variables. So we are writing basic variables are X2, S2, S3. Okay. Now, once we have got this is the basic variables and these are the non-basic variables, what is the coefficient of the basic variable? Can you tell me? See this table. What is the coefficient of the basic variable? CB? CB will be
400.
400. Right answer 400. See here, because if you are writing a code, I will request everybody, if you are writing code, you should write maybe either in Python or C++, whatever may be. So Python is very efficient, and you please, this is your assignment. If all the steps are clear, whatever the numerical example I have solved, using that as a test example, write code, and I will ask everybody to upload the Google Drive. Okay, I will tell you, you keep it ready and try to don't share the code with anybody, because if you are sharing, so your grade you will lose. Okay, so the final grade based on your work, how much you have understood and how much you are implementing. Okay, right? And there may be some mistakes in the numerical computation, so everybody should check and find the mistakes. Okay, this CB equal to, that is the coefficient of the basic variable for the objective function presently, that is 400. Once it is 400, we like to find y. What is y? So 400, y equal to CB transpose, that is the row vector, into B inverse. Which B inverse? Whatever the new b you are seeing, you are using the new b, you are calculating y. So what is their y? Can you verify it is becoming 200?
Yes, sir.
It is 200. Okay. Once you have got y equal to the row vector 200. Now next step, for the non-basic variable x1, x3, s2. Okay. For the non-basic variable x1, x2, s3, s1, x1, x3, s1. So what you should do? Calculate zj minus cj using this rule, y into pj minus cj. Now which column you have to use? P1. P1 is for x1, P3 for x3, P4 for s1. Okay. Z1 minus C1 equal to how much? Now what is Z1? Z1 minus C1. Z1 equal to y into Pj. Y is 200. So 200, you can see here 200. This 200. Okay. Inner product with 114. 200 inner product with 114. Then minus 1. How much it will be?
1.
1, sir.
Is 1. Similarly, 200, this table I am using, 200 inner product with third column, 1, 2, 1, 200 minus 4. How much it will
Minus
be?
2.
Yes,
Minus 2.
this will be
Minus 2.
minus 2. First one is positive, second one is negative, minus 2. Then Z4 minus C4 with respect to S1 column, 200 inner product with 100 minus 0. Then how much it will be? Yes, it is 2. Now say we have got this is 2. The elements, indicator row elements are 1, minus 2, 2. So now which one will select? Most negative, that is minus 2. This minus 2 is coming with respect to third column, x3. So x3 is selected as the new entering variable. If x3 is selected the new entering variable, if x3 is selecting the new entering variable, we will select P3 column as a new entering vector. Now, so in the step 1 itself, we have got the entering variables. Now we are interested to know what is our departing variable. What is our departing variables? See here, departing variable we have not got. In first attempt, we got S1 is the departing variable. Okay, and X2 is the entering variables. Now, in the second attempt, X3 is the entering variables. Now, which is the departing variable we want to know? See here, XB equal to B inverse into B. See, this small b is not changing. The capital B and its inverse is changing. Small b is not changing. No column is changing. So XB equal to B inverse into small b. Okay. This is our B inverse. Small b. What are the elements? I told 16, 14, 12. With respect to this B inverse, multiply 16, 14, 12. A column vector. How much it will be? XB. This is becoming, our XB is becoming B inverse into small b is becoming 8, 6, 4. Let us verify. We are multiplying how much? 16, 14 and 12. 16, 14 and 12. So first row, first column, 8. Second row, first column. Okay, how much it is? That is coming as 4. That is 16 minus 8, so 6. Okay, then that is 12. 12 means the third row, first column. 8 minus this 12 minus 8, that is 4. So 8, 6, 4. XB is becoming 8, 6, 4. B I am not changing. So using B, I have got XB equal to 8, 6, 4. This is our XB. So presently this is the, here itself you can see with in the XB itself. So what is there? We have our XB, this first element is representing what? X2. Second element representing S2. Third element representing S3. X2, S2, S3. Now we want to know, since we are using the entering vector P3, we want to know what is our alpha 3. Alpha 3 equal to B inverse into P3. If you multiply P3 with B inverse into P3, so our elements becoming half 3 by 2, 1 by 2. Half 3 by 2, 1 by 2. Okay. What is P3? P3 elements are 1, 2, 3. This you will do calculation. Now we want to have minimum ratio in this manner. Okay. So that is elements of XB, elements of alpha 3, respective, you will divide, only positive ratio will take, no question of negative ratio. So 8 divided by half, that is 16. 6 divided by 3 by 2, that is 4. 4 divided by half, that is becoming 8. So 16, 4, 8. 16, 4, 8. We are looking for minimum ratio. What is minimum ratio? Minimum ratio is becoming 4.
4.
Once you got the minimum ratio is 4, this 4 is coming with respect to middle element. There are 3 basic variables, X2, S2, S3. So the middle position. So that is the departing variable. So which one will be our departing variable? Yes. S2 is our new departing variable. Okay, S2. So I have told already X3 is the new entering variable. S2 is the new departing variable. Now, with respect to S2, what is happening? This P3 column elements are 1, 2, 1. This 1, 2, 1, this column will replace in S2 position because S2 is the departing variable. This house is now empty. So here the elements will be, instead of 0, 1, 0, the element will be 1, 2, 1. Okay, 1, 2, 1. So there are 3 columns. So earlier you have occupied the, see here, earlier you have occupied the first column. Now we are occupying the second column. Third column remain as it is, no change. So presently, what is your basis matrix? What is your basis matrix? 2, 1, 1, 1, 2, 1, and 0, 0, 1. Okay. So we are going to find the inverse of this basis matrix. Okay. See, I have told you, if you change first column, okay, only first column is different. We are finding E1. Say second column is different. So you will find E2. So using the product form of inverse, we will compute the inverse. See here, how to compute? Our B next inverse, that is E2 into E1. Whatever you have got, that is E1, E2 into E1. What is E2? E2 is an identity matrix. So very similar to identity matrix. The second column is different. Second column we have got. So we want to replace in the second column itself some eta vector. So from where you got? The elements are half 3 by 2, 1 by 2, alpha 3. The elements are half 3 by 2, 1 by 2. Because if you multiply with the B inverse, you will get this one. Now, the middle element is our pivoting elements. So this middle elements will be reciprocal. So this 3 by 2 is becoming 2 by 3. Then you divide with a minus sign. Then the first element is becoming minus 1 by 3. Then the last element also becoming minus 1 by 3. So these middle elements, middle column elements are minus 1 by 3, 2 by 3, minus 1 by 3. This is our E2. And already we have got E1 earlier. So multiply. So if you multiply, this is our inverse. This 2, 1, 1, 1, 2, 1, 0, 0, 1. If somebody computing fresh, so you can find this is the inverse. Okay. B next you have got, B next inverse is this. So this is nothing but B next inverse equal to E2 into E1. We are using product form of inverse, PFI. Okay, this we have got. Now our work is not complete. We want to make it complete. So we have got B, we have got B next. B, this is our B because we are replacing. So B next inverse is our B inverse. So B and B inverse are known to us. We want to know what is our basic variables. What are the basic variables? X2, X3, S3. These are the basic variables. What is our non-basic variables? Non-basic variables are X1, S1, S2. Now, come to the table. What is the coefficient of the basic variable here? Can you tell me? The basic variables are X1,
440.
X2, S3. So 440. So 440. We have got the coefficient is 440. You can see here 440. With respect to 440, we are interested to know what is our y, the row vector. Y equal to CB transpose into B inverse. This B inverse is already known, available. The 440 we are multiplying from the left. So if you multiply, what will happen to this? The elements will be 4 by 3, 4 by 3, 0. Okay. If X1, X2, X3, S3, these are the basic variable. Non-basic variables are X1, S1, S2. With respect to the non-basic variable, X1, S2, S3, X1, S1, S2, we like to compute Z1 minus C1, Z4 minus C4, Z5 minus C5. Why? This Z1 minus C1 with respect to first column, Z4 minus C4 with respect to fourth column. So Z5 minus C5 with respect to fifth column. See, second column, third column, and the last column. These are the columns for the basic variables. Okay. So if you compute, we are finding all elements are positive. That is 5 by 3, Z1 minus C1, Z4 minus C4, 4 by 3, Z4 5 minus C5, 4 by 3. So this indicates this is a optimal simplex table. Optimal simplex table. So once it is optimal, no need of computing any inverse further. So whatever inverse you have got, so using that you will have final solution. Our XB equal to X2, X3, S3. That is B inverse into B. This is the B inverse we have already got. You can see here 2/3 minus 1/3 0, 1 minus 1/3 2/3 0, minus 1/3 minus 1/3 1. So this multiply with original B 16, 14, 12. If you multiply, you are finding these elements are 6, 4, 2. What is 6? Value of X2 equal to 6. Value of X3 equal to 4. Value of S3 equal to 2. What is Z? Z is the value of the objective function. That is CB transpose into XB. CB transpose into XB. What is CB? 440. And what is XB? XB is 642. This 2 is for S3. Okay. So as a result, if you are multiplying, this answer is coming as 40. So X1 equal to 0, x1 is not there because basic variable x2, x3, s3. So x2 equal to 6, x3 equal to 4, and s3 equal to here 2 is not required to write, and value of our objective function equal to 40. So this problem, I will say that there is no alternate optimal solution because the non-basic variables, none of them are 0. That is 5 by 3, this is 4 by 3, that is 4 by 3. If by chance you are finding z1 minus c1 equal to 0, there is a possibility of finding alternate optimal solution. We have to search. Is it all right? Is it all right? So please note down one more problem. So I will stop here. Only this problem, and try yourself using revised simplex method. So in the test, the revised simplex method is included. Please remember this problem. Please note down R4 and tell me what is the answer you are getting. 2 line.
When is the test, sir?
You are worried only for the test. Test will be around 15th. So is it 15th around if it is Tuesday? So I am going to take the test on Tuesday, not Monday. Monday 2 hours, Tuesday is all right. Okay.
Okay, sir.
Whatever it will be covered up to 15th, that is included. Please remember. And test is objective type, and you have to write the numerical answer. Okay. Please note down this problem. That is a 2 variable problem, but our basis matrix will be 3 by 3. Don't solve it using graphical method. You solve it by revised simplex method. Is it all right? The problems, whatever I have given for homework. Okay. Hello?
Yes, sir.
That is for practice only, because there is no possibility to check. And if you are writing code, you can use my numerical example as your test example. Okay. Before submitting any code, you should certify that yes, it is working. It means you are able to solve such problems using your code. Okay. And if you find any mistake somewhere, you can tell me. This number 4 is you have noted down. The very simple problem, but I'm asking everybody, you make practice using revised simplex method. Simplex method, you know it. So simplex method, revised simplex method, any method you can. But here, so these problems are strictly for the revised simplex method. Okay,
Sir,
thank you.
Previous
stop
slide
here.
was-
I am sure you are not solving any problem. Are you solving any problem? See, I have given some problem for two-phase simplex method. Okay. Such problems also you can try using big M method. And this problem which is named for simplex method, you can try with simplex method. And this problem which is given for the revised simplex, also simplex you can apply, no problem. But try to use condensed form of simplex table if you are using right table. But if you are using the steps, what you have done here for the revised simplex method, so only first table is required, and using the first table, what is your answer?
Sir, can you tell the final answer so we can check?
Final answer. So x1 equal to 42. Okay. x1 equal to 42. x2 equal to 18. and Z equal to 132. See, in the revised simplex method, what you are doing? You are finding the product form of inverse. Okay. So using first inverse, you are computing the second inverse. Using the second inverse, you are computing the third inverse. Okay. So since the problem is either 2 variables, 3 variables, after 3-4 stages, you will find the solution. Okay. So only you have to use some matrix multiplication, nothing else. Okay. So if any difficulty, you can ask me. X1 equal to 42, X2 equal to 18, and Z equal to 132. That is the maximum value. And this problem has only one solution, one optimal solution. Okay. So I will stop here. Thank you very much.
Thank you, sir.
Thank you, sir.